Hey guys, so today you and I are going to talk about optimization. So let's get into it. So the question in question was, Frederick, why is it that so many people trying out coding is anti-optimization? Why are so many programmers anti-optimizing their code, especially in the Node.js and Ruby community? Because when you try to optimize something, one part of it is that a lot of people just kind of blindly follow the doctrine. And the doctrine is premature optimization is the root of all evil. Now you can go and have a look at that because that's a very famous saying of the programmer community. And so that's the one part, that people who actually follow that rule because they've just heard it, they don't actually understand what it means, but they just believe it because someone better and smarter than them have said it. And then you have the other group who actually know what it means, and they're usually against optimization because the cost value ratio is off. And what do I mean by the cost value ratio? Well, I'm very glad that you asked. This is the thing that the people who optimize things just never ever seem to understand. And that is that if you just say that you're going to optimize something, you are just expressing the fact that you're going to attempt to make something that is working work better. Now, what is the point of that? Just just think about it. Why are you trying to make something that is working and filling the need that you have do that even better? And most people who go into optimization, they won't actually have a good answer to that. They will not be able to say anything except for, well, it's running faster and faster code is better, right? Yes, it is true that faster code is better, but there's also a way off to that. If your solution ends up being more complicated, then the code gets more complicated, and complicated code is bad. And here comes the real big question: which is better, performant code or easy code? Which one? Now, for the average programmer, easy code is the best thing, because easy code is comprehensible. Easy code means that it's easy to change it, it means that it's easy to understand what's going on, and the odds of you being able to update that code without causing a lot of bugs and regressions is higher. Like, you will be able to deal with this problem because it's an easy problem. If you have a very complicated problem, something that is very performant but or highly optimized, but is in essence a lot more complicated, you might find yourself in a situation where nobody really dares touch the code, and a less skilled programmer might come along and try to tweak the algorithm or change it in some way, but they don't have the optimization part of the brain that the person who originally wrote it had. So they actually end up undoing the optimization in another fashion, or even worse, they might actually cause a lot of bugs. And so the end result, which is this balance that we are trying to figure out between time to market and stable software versus very performant software, that balance gets out of sync. And that is the struggle. If there is a very nice notion stating that you can pick between convenience and security. You can't have both. It's always a tug of war. They're always opposites. And very optimized code is almost always in opposition to very simple code. This is the struggle. So what you're trying to do is basically to find the sweet spot between something that works really, really fast and something that is very easy to develop and that makes people very productive. And in a community such as Ruby, the favor is very strongly towards comprehension and things like that. Node.js is a similar sort of beast. It's not as much as Ruby, because I think Ruby is probably the most famous community where if we talk about developer experience, I don't think anybody does as much of that as Ruby. Node and JavaScript, yes, to a point, but not in the same way. So they're similar, I would say. And so the real question here is, how do you find that sweet spot, because as I was saying, the people who just follow the rules saying that premature optimization is the rule of all evil, well, yes, no, it also, because another problem that is really problematic is if well, let's say that you actually ship something that is so it's very easy, it took a day to ship, but it's so gosh darn unperformant that it doesn't actually make your users happy, or it doesn't actually fulfill the requirements that you have. And that's usually the way it goes. You usually ship the simplest thing that you can build, and then you try to optimize it in hindsight. And now the optimization nerds, they will say, well, that's really bad, because it's actually, you could ship it immediately in a very performant state, which is, once and then we go back to the whole discussion, yes, you could do that, but what is the way of doing that? The valid argument from the optimization perspective, at least if you ask me, is that the problem with shipping an unperformant solution to start off with is that code is hard to change in many cases when it's established, because the cost of changing something is usually higher than getting it right on the first go. Now, that's not a universal rule. I'm just saying that, as you can imagine, if you have a single function that does some transient operation in memory, it doesn't persist anything, doesn't do anything, it's just, I don't know, it filters something, what doesn't really matter, and that only exists in memory for the lifetime of the request, well, the cost of you fixing that after you've shipped the code is pretty low. You can change it whenever you feel like it. But on the other hand, if you are dealing with, say, records, if you're persisting things to a database, or you have an unperformant query or something even worse, like a transaction or something like that, well, now all of a sudden you actually are in a pretty big pickle, because fixing that for performance optimizing that is actually much more expensive, because you might have data that is persistent, you need to move it around and do migrations and all this other fun stuff that the YouTubers out there won't tell you that you need to know. And that is the real problem. And so many communities, they try to push that simple code is better, because it's more common for you to have a problem with bugs and time to market than it is for you to have a problem with unperformant code. The thing that I think that you should really remember, though, is that just because there is a rule saying that premature optimization is the root of all evil, that is a rule that we have just in the same way we tell a child not to play with matches. It's a rule that we put in place so that we will stop them from burning their fingers. But an adult can absolutely play with matches, because they have matured enough to understand when an optimization is very appropriate and when it's not appropriate. At least I'd like to think that way. So, what I want you to take away from this is that the most common reason why people are anti-optimization is, one part, like half of them are just repeating premature optimization is the root of all evil, and like the other half know what it actually means. But they both kind of agree on the fact that, well, optimized code or highly performant code is usually much more arcane. It's harder to work with, it's harder to understand, comprehension, all that sort of stuff goes down if you have a solution like that. I mean, the sweet spot is, of course, if you the super genius optimizer can come up with a solution that is super performant but very easy to consume as well. That's when we come to libraries and abstractions and all this other nice stuff that you can do. And the very nice people who work on our runtime environments and compilers and stuff like that, these unsung heroes are trying to do that exact thing for everybody, so that we like monkeys, we can just write things in a file, and then the runtime or the compiler takes care of everything else, all of our mistakes. That would be great. So that is the one part in the whole thing. And the optimizers usually say that, well, optimized code and shipping things that are optimized by default actually is cheaper for you, because if you have to go and change it afterwards, that's going to be a problem. And that is true to a point. In some cases, it's actually really hard to fix an issue that has to do with performance afterwards. But for most companies, the trade-off is just not worth it. It's a similar situation as with security. Anybody who's in the security space will tell you that for most companies, security is an afterthought, because it's a cost that you would have to pay before you actually need it. And we can debate back and forth whether or not that makes sense, but that is the way that things work. And optimization nerds are in the same sort of situation. Unless they can very clearly prove that this optimization is very, very valid, usually they're going to have to fold to the pragmatist who just wants to ship something as quickly as possible with the fewest amounts of bugs. Have a great day.